Hi everyone. Today let us do some example sums related to proofs of irrational numbers. This is example 9 from your textbook. Prove root 3 is irrational. Now let us prove this root 3 is irrational. To prove this root 3 is irrational, first of all let us assume in contrary that root 3 is rational number. Okay, let us assume root 3 is rational number. In contrary to the irrational, we think it as first rational number. If it is a rational number, then root 3 can be expressed as rational number form. Expressed as rational form. Rational number form means like in fraction form. Rational number form like either p by q or a by b, something like that. So root 3 is equal to, we write a by b, where a and b are integers and b is not equal to 0. Okay, this is the definition for rational number. But here let us think this a by b is in simplest form. Let us think a by b is in simplest form. That means we should understand that a and b have no common factor other than 1. That means a, b have no common factor other than 1 and it's in simplest form. Other than 1. Next. That means you can also say that a and b are co-prime also. They can also call as co-prime, which have no common factor other than 1. We can call them as co-prime also. Okay. So whenever root 3 is equal to a by b, let us write it as a is equal to, like cross multiply or send b to the other side. A is equal to root 3b. A is equal to root 3b. In this, now let us square on both sides. Let me move a little bit up. And now write squaring on both sides. Squaring on both sides. We have a becomes a square, root 3 becomes 3, b becomes b square. So a square is equal to 3b square. If you square on both sides, you will get a square is equal to 3b square, which is keep as number 1. Now, this means if a square is equal to 3b square means a square is equal to 3 into some number. Some number means you should understand that 3 divides a square exactly. So 3 divides a square. So therefore 3 divides a square. So if 3 divides a square, by theorem 1.3, what we have learned in the previous video, we know that in theorem, theorem point 1.3 says, it says that if p divides a square, then p also divides a. So from this statement, you can apply that theorem 1.3 and say that 3 divides a also. 3 divides a. So now coming to this. Next, now if we can write like if 3 divides a, we can write that means a is equal to some 3 into some integer c. 3 divides a means a is a multiple of 3. So 3 into some integer where c is an integer. Where c is an integer. Now substituting this value a is equal to 3c, substituting this value in 1. So we can have that a square is equal to 3b square, right? A square is equal to 3b square from 1. So I'll substitute this a is equal to 3c in 1. So a square means I'll write it as 3c whole square, which can be written as 3b square. 3c whole square means it is nothing but 9c square, which is 3b square. Now you can also cancel 3 1s and 3 3s. So we can write like 3c square is equal to b square, or b square is equal to 3c square. What do you understand from here? Again, b square is equal to 3 into some integer. B square is equal to 3 into some integer. That means 3 divides b square exactly. So we can write therefore 3 divides b square. 3 divides b square. So if 3 divides b square, again from theorem 1.3, what it says? If p divides a square, if p divides a square, then p also divides a. So similarly, we can write like 3 divides b also. So now coming to here, you have here 2 points. Here we got 3 divides a and here we got 3 divides b. So what do you mean by this? That means we should understand that 3 divides both A and B. If 3 divides both A and B, what do you mean by that? 3 is a common factor for A and B. So 3 is a common factor for A and B. But this contradicts that the fact that we understood in the starting, we understood that A and B have co-prime. Let me go back and show you. We have, think here, A and B are co-prime. A, B have no common factor other than 1. That means A and B are co-prime. They don't have any common factor other than 1. So what do you mean by that? But we have here 3 is a common factor for A and B. So that means this contradicts our fact that A and B are co-prime and they do not have any common factor other than 1. So this contradiction, so we write, but this contradicts the fact that they do not have any common factor. They are co-prime. A and B are co-prime and they do not have common factor. Other than 1. So this fact is contradicting for us. Then, so this contradiction arises due to our incorrect assumption in the starting itself. This contradiction arises due to or because of our incorrect assumption. What did we assumed in the beginning? We assumed that root 3 is irrational. Incorrect assumption that root 3 is rational we thought. So, but because this contradiction arised, we can say now, we can conclude that finally, because of this contradiction, we can take back our sentence that root 3 is rational and can say, conclude that root 3 is irrational. Okay. Next, go to the example 10. Now let us see the example 10. Show that 5 minus root 3 is irrational. We need to show that 5 minus root 3 is irrational. That means the difference between a rational number and irrational number is an irrational number. We need to prove that the difference between a rational number and an irrational number is a rational number. We are going to prove that. So, okay, like before, here also let us assume to the contrary that 5 minus root 3 is rational in the beginning. Let us start with, let us assume to the contrary that 5 minus root 3 is rational number. Okay. So if it is a rational, what happens? This 5 minus root 3 can be expressed in the form of a by b form, like fraction form. So let us assume that 5 minus root 3 should be equal to in the form of a by b. Okay, where a and b are co-prime. A, B are co-prime. Means A by B is a simplest form. This is already in simplest form. A and B are co-prime. That means A and B do not have any common factor other than 1. So you can think like 5 minus root 3 is in simplest form of A by B. Now let us bring A by B to this side and send root 3 to the other side. So 5 minus A by B is equal to root 3. Okay. Next, by taking LCM and subtract these two, B is the LCM. Into B, 5B minus into 1 A is equal to root 3. Now, as you understand here, A and B are integers. That means this whole thing 5B minus A by B is also a rational number because numerator is an integer, denominator is also an integer. If numerator and denominators are integers, this whole becomes a rational number. So, because of A and B are integers, let us write as A comma B are integers. this 5b minus a by b is a rational number. That means if this is a rational number, what happens to this root 3? Root 3 also should be a rational number. Root 3 also a rational number. But is it a rational number? We already proved that root 3 is not a rational number. It is irrational. We just proved in the previous example. So root 3 is this is a contradiction. So this is a contradiction as root 3 is not rational. So we can say that root 3 is irrational. We know that root 3 is irrational. So this contradiction, why did it arise? It arose due to our incorrect assumption in the starting. So what did we assume in the beginning? That 5 minus root 3 is a rational number we assume. This contradiction arose due to our incorrect assumption that 5 minus root 3 is rational. We assume like this. So because of this contradiction, now you can finally write that. Therefore, we can conclude that 5 minus root 3 is irrational. 5 minus root 3 is irrational. That means we proved that the difference of a rational number and an irrational number is always irrational. Now you can remember that the difference between any rational, 5 is a rational, root 3 is irrational. So the difference between a rational and irrational is always irrational. Okay. Now let's go to the next example. Now let us see example 11. Show that 3 root 2 is irrational. We have to show that 3 root 2 is irrational. That means it's a product of a rational and irrational. The product of a rational and irrational is irrational. We need to prove this. Okay. So let us assume like in the as before. Let us assume same as before. To the contrary, that 3 root 2 is rational. We think it as rational for time being. For example, this is not irrational. We are thinking it as rational. That means we can express in the form of 3 root 2 can be expressed in the form of fraction like a by b, where a by b is in simplest form. That means a and b are co-prime as usual. A and b are co-prime. That means they don't have any common factor other than 1. It is in simplest form. Okay. Now coming to here. Let us send 3 to the other side. If you send 3 to the other side, we will get root 2 is equal to a by 2b. Sorry, 3b. A by 3b. Now, as a, 3, b are all integers. A is an integer, b is an integer, even 3 is also an integer. So, numerator is an integer, denominator is also an integer. So, that means a by 3b is a rational number. As a, 3, a, b are all integers, a by 3b is a rational number. Is a rational number. If it is a rational number, what happens to this root 3, root 2? Root 2 is also a rational number. If a by 3b is equal to root 2, right? So, if this is a rational, root 2 is also a rational. Root 2 is also a rational. But root 2 is also a rational. But what do you understand? But already we proved and we have already learned that root 2 is irrational. We already proved and we learned that root 2 is not rational. So, root 2 is, but you write, but root 2 is irrational. So, this contradiction arised. Again, contradiction arised. This contradiction is due to because of our incorrect assumption again. So, this contradiction has arisen due to our incorrect assumption that 3 root 2 is rational. We assumed in the beginning 3 root 2 is rational. So that means because of this contradiction, now we can take back our word that, and we can conclude that 3 root 2 is not rational, is irrational. So from this we can understand that product of a rational and irrational is again a irrational number. So always the product of rational and irrational is irrational. Previously we proved that the difference between rational and irrational is irrational, and this is product of rational and irrational is also irrational. Okay. And we'll see exercise 1.4 in the next video.